In this video, I'm going to show you step by step how to do microscopy calculations. So we're going to look at total magnification, how to calculate field diameter, that proportion given knowns of another field diameter, and then we'll look at estimating cell size. So let's start with total magnification. And in general, you're going to use the same 3 steps. Step 1, write out the formula. So you'll need to know that the formula for total magnification is the magnification of the ocular lens times the magnification of the objective lens. So where do you find that information? You'll find it on the microscope, or in this case, it's right in the question. So we know that 10x is for the ocular, and we know that 45x is for the objective. The next step is to plug in those numbers. So I'm going to plug in my numbers. And then I do the arithmetic, which is step 3. So if I multiply 10 times 45, I arrive at a total magnification of 450x. The x is a symbol we use in science to indicate magnification. So now we're going to calculate field diameter. So in order to do that, we have to know 3 things. We have to know the field diameter having been measured or given to us of another objective or objective lens. We have to know the total magnification of lens A and lens B. So let's start out and write the formula. So I've written out my formula, and I've written the variables in different colors so I can show you where I'm obtaining the known values. So what I have is FD, which stands for field diameter. Field diameter, remember, is if you're looking through the ocular lens at the lighted field, field diameter is the distance across the entire field, the diameter of that circle of light. So the field diameter for A, I've been told, is 6 millimeters or 6,000 micrometers. So we're going to work with millimeters. So that's where I get this value. Then I need to plug in the total magnification for the 4x objective. So I remember that total magnification is the product of the ocular lens times the objective lens's magnifications. So I know I'm using the 4x objective, and my total magnification would be 10 for the ocular times 4 for the objective. So the value here is 40. So when I get to the field diameter of B, that's my unknown, because I'm told in the question, calculate the field diameter for the 40x objective. So here, I'm just going to put in a B. So you can use X and Y, you can use Q and P, whatever letters you want to use that makes sense to you. So next, I have to figure out my total magnification of B. And just like we did previously, I again remember that total magnification is the product of the ocular lens's magnification times the objective lens's magnification. So I'm going to work with the 40x lens here, and I know that that would be 10 times 40. So the total magnification of lens B is 400. And that's probably the most difficult part, is figuring out just how to set up the equation. So make sure you practice that and you know what the formula is. And then we can go on to step 3. So in step 3, I'm simply doing the arithmetic, but I know it's been a little while for some of you, and you want to make sure that you're doing the mathematics correctly. So let's do out all of those steps. So I know, or I can multiply on a calculator, 6 times 40 would give me 240, and I retain my unit, equals B times 400. In order to isolate the B, because that's the value I'm looking for, I now have to divide both sides by 400. That's how I get rid of the 400 next to the B. So these two cancel out, or you can think of it as 400 divided by 400 is 1, so I'd be left with 1 times B. And then I also have to do that on the other side. So what I got was 0.6 millimeters equals B. Now there is a way that you can double check yourself. And this, if this part doesn't make sense to you, that's totally okay. It's just for the people that want to see some more logic. So the 40x objective has magnified the field 10 times further than the 4x objective. And in doing so, the field becomes 10 times smaller. So I originally had 6 millimeters, 10 times smaller using the 40x objective gives me a field that's 10 times smaller. And again, if that didn't make sense to you, just, leave it off to the side. So this question tells me that I need to calculate field diameter in both millimeters and micrometers. So let's do that. Let's do that conversion. So in order to convert your millimeters to micrometers, you have to multiply by 1,000. So I've set up the equation. My known was 0.6 millimeters. I also know that the conversion factor for millimeters to micrometers is that there's 1,000 micrometers for every 1 millimeter, similar to the fact that there are 12 inches in every 1 foot. We're just using metric units instead of English units. So I do the mathematics like this. I cross out, I have cancellation of millimeters. The unit I'm left with is my micrometers, so that's going to carry over here. And then I just multiply 0.6 times 1,000, which would give me 600 micrometers. So let's say I want to do that conversion the opposite way, that I want to convert micrometers to millimeters. So I'm going to use a different number just so that we don't confuse the top and the bottom. So in this case, let's say that I have 3,750 micrometers, and I want to see how many millimeters that is. So in this case, instead of multiplying, because I'm going from a smaller unit to a bigger one, like pennies to dollars, then I'm going to divide by 1,000. So I have my 3,750 micrometers. I know that my conversion factor is still 1 millimeter per 1,000 micrometers, but I want to make sure that I can carry over the millimeters to the answer. So I would cancel micrometers, and that's going to leave me with the millimeter unit to carry over here, And in this case, I would be taking the 3,750, dividing it by 1,000, which will give me an answer of 3.75 millimeters. So the last thing we'll do is look at how do you estimate cell size. So remember, this is an estimate. It's not an exact. You're not using a calibrated ruler to measure the size of the cell. So let's look at this neuron. So we know a couple of things. We know that we're using the 40x objective. We've been told in the problem that the field diameter is 0.5 millimeters. So you can do this. And then we'll follow step 1. Write out the formula. So I know from the information given in the problem that my field diameter is 0.5 millimeters. And remember, we found that up here. So I'm going to plug in 0.5 millimeters. And now I have to figure out how many cells do I think fit across this field. So I'm looking at a single neuron here at the end of the red arrow. So I can do this a couple of ways. Visually, I could say, I think maybe 10 cells fit across. If I was doing this on paper, I could kind of draw in some cells and estimate their size. And you can see I'm not being super consistent about size. I'm just trying to make an estimate. So I have half a cell here. 1, 2, 3, 4, 5, 6, 7, 8, and then say another half. So I'm thinking about 9 cells. So then I have to do step 3, which is do the arithmetic. In this case, I would definitely grab my calculator. So in this case, I do out the mathematics on my calculator, and I come up with an answer of 0.055555, a bunch of 5s, ending with a 6. I think it's 0.05 repeating. So generally, I'd be told in a question, if this was a lab practical, calculate out to, say, the 100th place or the 10th place. So make sure you go back and review some of that basic mathematics if you're not quite sure about that. So here, I'm going to go out to the 100th place. So that means that my cell size would be about 0.06 millimeters. If I wanted to convert that to micrometers, I would multiply by 1,000, just like we did in the previous step, and that would give me 55.6 micrometers. If you just took the 0.06 millimeters and converted that to micrometers, you would end up with 60 micrometers. So I hope that helped. Just keep practicing